Hello students, welcome back. So now we are going to be focusing our attention on ROC AUC. ROC stands for Receiver Operating Characteristics and AUC stands for Area Under the Curve. People when they use the term, they really don't use these terms, they use ROC AUC curve. So ROC, it is a metric. It actually measures the performance of your binary classifier. Your ROC, it measures how many good positives that we were able to capture. Another name for that is TPR, true positive rate, versus how many mistakes we made. And another name for that is FPR, which is false positive rate. Your true positive rate would be coming from here, this right here, and your false positive rate, you will be getting it from here. Now, this is your confusion matrix. This one is the actual, this one is the predicted. This number 600 is telling me that the actual was A, there was 600, there was actual way A, and they were predicted to be A. So this is my true positive. Fn is your false negative. That tells you that there were 300 of them. There was actually A, but they were predicted to be class B. So this is 300. And this is how these metrics are read. This is how you read these confusion matrix. So why does ROC exist? Why do we need this matrix? Well, most beginners, they think that your model, that your machine learning model, they output labels, that your binary classifiers, they are outputting labels. But your models, your binary classifier, they actually output probability. So for example, let's say you have persons A, B, C, D, and your model is going to output the probability of a person whether he has a cancer or not cancer. For example, A is a 95% chance he has a cancer. B is 80% chance, C 60% chance, and D is 30% chance. And what we do is we convert this probability is using a threshold. So we say that let's say the threshold is 50%, 0.5. So if the probability of a person having a cancer is more than 50%, then we are going to say he has a cancer. So based on this threshold, your ABC, that would be this person, and this person. These three person, they have cancer. On the other hand, this person does not have cancer because his probability, his threshold is less than 0.5. What ROC does, it shows what happens when we change this threshold for the binary classifier. So this is the intuition that if your threshold is 0.9, then your result is going to be very strict. That means do not make many mistakes. That's what you're saying over here. So if your threshold is 0.5, you are going to be having a balance. On the other hand, if you say 0.1, okay, let's say you set up your threshold as 0.1, then it's going to be very lenient. In other words, you are going to catch more positive, but you increase the risk of false alarm with low number. So what exactly is an ROC curve? Well, ROC curve, as I explained before, is a receiver's operating characteristic curve, and the term comes from a radar system that was designed in World War II. ROC curve, it plots x-axis and y-axis. Your x-axis, that would be your FPR, that is your false positive rate. Your y-axis, that would be your TPR. This is called true positive rate. And we plot this thing based on different threshold of your probability. So how do you calculate this TPR and FPR? Well, we can derive our TPR and FPR from the confusion matrix of the binary classifier. Suppose we choose our threshold as 0.5, and this is the confusion matrix I get from this binary classifier. So in this case, my TPR is going to be equal to your TP, which is your true positive, divided by the total of your class A. So TP divided by TP plus Fn, and in this case, it's going to give me 0.67. So it tells me that this particular model, it successfully detected 67% of your class A. Suppose class A could be like the mails are spam, and class B could be that the mails are not spam. So in this case, it detected 67% of all your spam emails. FPR, on the other hand, that would be this right here, that's going to be equal to your false positive divided by the total of your class B. So in this particular instance, my FPR comes out to be 0.01. It means that this binary classifier, it falsely flagged 1% of your class B, in other words, your legitimate email, as spam. So what ROC curve does, it shows the performance of your binary classifier with different decision threshold. So it plots your FPR and TPR against various threshold. So for example, if your threshold is zero point 0.3, so let's say your FPR and TPR comes out to be zero point 0.2 and zero point 0.6. So that would be a point, maybe this one right here. Okay, so let's say this is your point that actually plots. Then let's say for threshold equal to zero point 0.7, you calculate your FPR and you calculate your TPR, and it comes out to be, let's say, zero point 0.6 and zero point 0.8. That would be this point right here. So this is my zero point 0.6 and this is your zero point 0.8. So you plot all these points for various threshold, each one of them, and this is how you get this ROC curve right here. You connect all these points together, and this is your ROC curve. And now AUC. AUC means area under the curve. It measures how good your binary classifier model is at separating classes. Now, ROC AUC score is a metric. It is used to evaluate the performance of your binary classifier. So, let's say this is your ROC curve right here. Your AUC would be this area right here. So, the area under the curve, that is called AUC. Now, there are various values of AUC you're going to get. So, what do you mean by this AUC? What these numbers they represent? Well, if your AUC, let's say 0.5, that would be this right here. So, let's say this number would be 0, and this is going to be 1, and this is going to be 0 to 1. So, this is my FPR, and this is my TPR. So, if my area under the curve is 0.5, that means this model right here is making a random guess. So in this case, your AUC is going to be zero point 0.5, that is half. On the other hand, if your model is good, let's say it's making a pretty good decision, so in that case, your AUC, that means your area under the curve, is going to be higher than 0.5. So your curve may look something like this right here. Ideally, you want your curve to be like that, as close as possible, like this. So in this case, when your curve is going like this, almost like a rectangle, your area under the curve is going to be 1. That would be this right here. So this will be a perfect model. On the other hand, if your model is worse than a random, okay, that will be this right here. So your area under the curve is going to be less than 0.5. One thing I want to mention about this random classifier, what do you mean by random classifier? It means it's just randomly picking numbers. It's basically flipping a coin and just saying, okay, this is class A, this is class B. So it's not really doing any job. It's not doing any good job. So in this case, this is what you mean by random guessing. So your random model is going to have an AUC of 0.5. You want AUC higher than 0.5. That would be in this area. Now, if your model is correct in all the predictions all the time, it means your TPR is always going to be 1 and your FPR is always going to be 0. In this case, it means that it finds all the cases and never gives false alarm. So in this case, this is how your ROC curve will look like this right here. This is going to be perfect ROC. In this case, your AUC is going to be equal to 1. So how do you use this AUC concept in your real life? Well, the idea is this. You train multiple models. Let's say you have a logistic model, random forest model, XG boost, and you compute AUC score for each one of them. Let's say your XG boost model, it gives you AUC score of 0.91. This is how the curve looks like right here. And let's say for your random forest right here, your AUC score comes out to be 0.86. That would be this curve right here. And let's say for your logistic model, logistic regression, your AUC comes out to be 0.78. That would be this right here. So you compare your AUC and you choose the best ranking model. In this particular instance, your best ranking model would be XG Boost because this is giving you a higher AUC. That would be this right here. Now I'll show you how to plot ROC and AUC curve. So first thing I'm doing, I'm importing my necessary libraries right here. So I'm importing ROC curve right here. I'm also importing AUC. I'm also importing this function called make classification. This is responsible for creating a data set for me. In this instance, I'll be using logistic regression model. So I'm creating a data set right here. I'm creating 1000 samples. And then from collections, I'm importing counter. I want to know how many in my label. This is my target Y. I want to know how many were class 0 and how many are class 1. So when I run this, it tells me for class 0, there are 502 instances, and for class 1, there are 498 instances. So that seems to be a pretty balanced data set. Now I want to print out the first 5 records of X and also the first 5 records of my Y, just to see what's inside my data. So when I run this, it tells me, there you go. So these are my first 5 records. This is my first record right here, first value of X. This is my second value and third value and fourth and fifth right here. And these are my corresponding label for each one of them. Okay, then I train my model, logistic regression model. So I train my model, and there you go, it's trained. And now after this, I'm actually asking it to predict for my x. I'm asking it to predict the probability for every value of x now. So it makes a prediction. Then I'm supplying my prediction in the ROC curve. I'm supplying y, which is the actual, and I'm also supplying the predicted probability. And this is going to give you me my threshold and also my TPR and FPR. Okay, it gives me all this number. Then I feed my FPR and TPR to my AUC function. That's going to calculate AUC score. And now I'm printing my FPR, TPR, and threshold right here. So these are my false positive rate right here. And these are the corresponding true positive rate. And these are the threshold for each one of them. Okay, it prints out all these numbers right here. Then coming down, I want to plot that. I want to plot FPR with TPR, and I'm giving some labels over here. So when you come down, and you can see that now, let me decrease the size of the screen so it's a little bit more visible. And you can see that this is my false positive rate, this is my true positive rate, and this is the actual one, this one right here. And in this case, my AUC score is 0.94. So I'm printing out the ROC AUC score. So this thing is this one is doing pretty good job in classifying, and you can see that your number is 0.94. So anytime when your curve is almost like a rectangular shape, it's closer to this axis and this axis, that it means it's doing a good job. This is your random classifier. Okay, in this particular instance, now I also want to plot my confusion matrix. I want to see how my confusion matrix looks like. So in this case, I'm calling this confusion matrix. I'm also calling confusion matrix display. This is going to show me, it's going to give me visual representation of the confusion matrix, and I'm plotting the confusion matrix, and there you go. These are this is how the numbers are showing. So 84%. Okay, the true label is 0, and it was predicted label was 0. So 84% it got it right, and 88% it got it right for class 1. So the true label was 1, and the predicted was 1. So this is good. On the other hand, 16% and 12% over here, it got it wrong. Okay, so it seems like it's doing a pretty good job.